Hi, today we try to discuss the art of ensuring integrity. So, in this, the basic objectives of this art of ensuring integrity chapter is one is the type of data integrity controls. We'll discuss this, and the digital signatures, certificates, that digital certificates, and the database integrity enforcement. So these are the basic objectives that we are going to talk more about this. So in the types of data integrity controls, it basically explains the process that used to ensure the integrity. We talk more about it in terms of hash functions. Then digital signatures. So this is the purpose of digital signature. So we talk each of these objectives in detail. So, first is the types of data integrity controls. So, in integrity ensures that data remains unchanged and trustworthy by anyone or anything over its entire life cycle. Data integrity is a critical component to the design, implementation, and uses of any system that stores, processes, or transmits data. So, in this lecture, we begin by discussing the types of data integrity controls used, such as the hashing algorithms, salting, and keyed hash message authentication code, the use of digital signatures and certificates incorporate the data integrity controls to provide users a way of verifying the authenticity of messages and documents. So, in this lecture, we conclude with a discussion of database integrity enforcement. So, having a well controlled and well defined data integrity system increases the stability, performance, and maintainability of a database system that we discuss, right? So, here, yeah, this is what we just explained to you. So, what is hashing? So, users needs to know that their data remains unchanged while at rest or in transit. Hashing is a tool that ensures data integrity by taking binary data, that is the message, and producing a fixed length representation called the hash value or message digest, as shown in the figure. You can check it out. Okay. So the hash tool uses a cryptographic hashing function, this is a hash function, to verify and ensure data integrity. It can also verify authentication. Hash function replace clear text password or encryption keys because hash functions are one way functions only. These hash functions, right? So so this means that if a password is hashed with a specific hashing algorithm, uh, then it will always result in the same hash digest. So it is considered one way because with the hash function, it is conceptually infeasible for two different sets of data to come up with the same hash digest or output. So every time the data is changed or altered, the hash value also changes. Because of this, cryptographic hash values are often called digital fingerprints. So they can detect duplicate data files or file version changes and similar applications. So these values the guard against an accidental or intentional change to the data and accidental data corruption. Hashing is also very efficient. A large file or the content of an entire disk drive results in a hash value with the same size. Right? So then we'll see what are the hashing properties. So hashing is a one-way mathematical function that is relatively easy to compute but significantly harder to reverse it. So grading coffee is a good analogy of one-way function. Sorry, grinding coffee is a good analogy of one-way function. So it is easy to grind coffee beans, but it is almost impossible to put all of the tiny pieces back together to rebuild the original beans. So a cryptographic hash function has these following properties. The input can be any length, the output has a fixed length, the hash function is one way and is not reversible. So, two different input values will almost never result in the same hash value. So, then in this type of data integrity control and in the hashing algorithms, let us see the simple example of this hashing function. So, hash functions are helpful to ensure that a user or communication error does not change the data accidentally. So, for instance, a sender may want to make sure that no one alters a message on its way to the recipient. The sender device inputs the message into a hashing algorithm and computes its fixed length digest or fingerprint. So there is a simple hash algorithm called 8-bit checksum. So a 8-bit checksum is one of the first hashing algorithms, and it is the simplest form of a hash function. And 8-bit checksum calculates the hash by converting the message into binary numbers and then organizing the string of binary numbers into 8-bit chunks. The algorithm adds up the 8-bit values. The final step is to convert the result using a process called two's complement. The two's complement converts a binary to its opposite value and then it adds 1. That means if there is a 0, it converts into 1. If there is a 1, it converts into 0. And once all the 8 bits are inverted, then in the final step, it is going to add 1, that resulting in the 8-bit hash value. So this means that the 0 converts to 1 and 1 converts to 0, and the final step to add the 1, resulting in an 8-bit hash value. So here we can see the example. So to calculate the 8-bit hash value for the message which is sent from Bob to Alice, you please click here so that you can find the link where you can calculate the 8-bit hash for the message, given message. So here you see in this example, uh, uh, the convert BOB, that Bob message, the message is BOB here. So convert this BOB to binary using the ASCII code, the ASCII code for this B, O, and B. You can see here for B, the ASCII code is 01000010. For O, the ASCII code is, for capital O, the ASCII code is 0100 and all ones. So that is the first step in the 8-bit hashing or the 8-bit checksum. Next, convert this binary number to hexadecimal. Convert these binary numbers into the hexadecimal. So the message to be hashed is BOB. We have seen its ASCII values is this. Then sum these bytes. So that is convert these binary numbers into the hexadecimal form. So this binary number is equal to 42 in hexadecimal format for B. For O it is 4F hexa value, and for B it is 42 hexa value. When summing this entire message into hexa, it is D3 hexa value. Next, enter the hexadecimal number into the calculator. Okay, so where you can use the previous slide link to calculate this hexadecimal value. Okay, so by just entering this hexadecimal into the calculator, like 42, 4F, and 42. Okay, so then click the calculate button in the calculator. The result is the hash value that will get the 2D. 2D. Once doing for this BOB, we will get the 2D value. Right? So this we call the hashing one. First, convert the binary number into hexadecimal, then convert into the binary number into hexadecimal, then enter these hexadecimal numbers into the calculator. So you can click here for calculating that. So you will get 2D result here. So you can try this following example also for this 8-bit checksum. That is, the secret means we say the key for this secret message. These are the hexadecimal numbers. That is, the ASCII value is converted into the ASCII value is in the binary form that converts into hexadecimal. And when you add all these, then you will get the hash value like 3. You can try for these two also, this example. So then we talk about the some of the modern hashing algorithms. So there are many modern hashing algorithms widely used today. Two of the most popular are MD5 and another one is the secured hash algorithm. So in this MD5, also called as your message digest. So Rand Travis developed the MD5 hashing algorithm, and several internet applications use it today. So MD5 is a one-way function that makes it easy to compute a hash from the given input data, but makes it very difficult to compute input data given only a hash value. So MD5 produces a 128-bit hash value. The flame malware compromised the security of this MD5 in 2012. The authors of the flame malware used an MD5 collision to forge a Windows code signing certificate. So, whereas for this MD5, I will give you the link to read and the explain more about this MD5 uh, algorithm. Okay, so in this, another one is the secure hash algorithm. This secure hash algorithm, the US National Institute of Standard and Technology (NIST) developed the secure hash algorithm. The algorithm specified in the secure hash standard, that SHS. So National Institute of Standards and Technology (NIST) published SH1. Your SH2, this SH1 is published in 1994. SHA2 replaced SHA1 with four additional hash functions to make up the SHA family. That is SHA224, that is 224 bit. Another one is SHA256. The digest size is 256 bit, the hash value size. Another one is SHA384. So the digest size is 384 bit size. Another one is SHA512 bit. So this SHA2 is the stronger algorithm, and it is replacing the MD5, SHA256, SHA384, and SHA512 are the next generation algorithm. But this SH2 is these standards replacing this MD5. Okay, so now let us see the hashing files and the digital media. The hashing files, digital media. So integrity ensures that data and information is complete and unaltered at the time of its acquisition. So this is important to know when a user downloads a file from the internet, or a forensic examiner is looking for evidence on digital media. To verify the integrity of all iOS images, the one of the company, the Cisco, that provides this MD5 digest comparison. So this Cisco provides this MD5 and SHA checksum at Cisco's download software website. The download software website. So the user can make a comparison of this MD5 digest against the MD5 digest of an ISO image installed on a device, as shown here. You can see the version. So MD5 checksum and the installed version checksum. It is going to compare this checksum here. So the user can now feel confident that no one has tempered or modified the iOS image file. So here note that the command verify or MD5 the command which we are using, verify by your MD5, that so is beyond the scope of our discussion here. So this field of digital forensics uses a hashing to verify all digital media that contain files. For example, the examiner creates a hash and a bit for bit copy of the media containing the files to produce a digital clone. The examiner compares the hash of the original media with the copy. If the two values matches, the copies are identical. The fact that one set of bits is identical to the original set of bits establishes fixity. So, fixity helps to answer several questions. Does the examiner have the files he expects? Is the data corrupted or changed? Can the examiner prove that the files are not corrupt? So now the forensics expert can examine the copy for any digital evidence while leaving the original intact and untouched. So this is the hashing files and digital media. Next, we'll look into the hashing passwords. So here you can see for the user account registration and authentication, hashing algorithm turned any amount of data into a fixed length fingerprint or digital hash. A criminal cannot reverse a digital hash to discover the original input. If the input changes at all, it results in a different hash. This works for protecting passwords. A system needs to store a password in a form that protects it and can still verify that a user's password is correct. So, in this figure, it shows the workflow for user account registration and authentication using a hash based system. The system never writes the password to the hard drive, it only stores the digital hash. So for the user account, to create the user account, the system hashes the password and stores that hash in a database, and that stored hash value for password is in the form of the hexadecimal number. For authentication purpose, the system compares the hash of the password which is entered by the user to the stored hash value. When these two hash values are matching, if they match, the system grants the user access. If they don't match, it denies the access. So this is hashing the password. Now let us see the hashing algorithms in terms of its applications. So in hashing, the applications, it used the cryptographic hash function. In this situation, this cryptographic hash function, in the some of the situations, like to provide a proof of authenticity when it is used with a symmetric secret authentication key. The same key is used for encryption purpose and for decryption purpose, such as the IP security or your routing protocol authentication. And the cryptographic hash function, this is to provide the authentication by generating one time and one way responses to challenges in authentication protocols. And this cryptographic hash function also used in the situation to provide message integrity check proof, such as those used in digital signed contracts and public key infrastructure certificates PKI, where two different keys are used, that is asymmetric keys are used. One key is used for encryption purpose, another key is used for the decryption purpose. So these keys we say private key and public key. So, like those accepted when accessing a secure site using a browser. So, when choosing a hashing algorithm that uses the secure hash algorithm 256 or higher, as they are currently the most secure, right? So, by avoiding secure hash algorithm one family and message digest 5, that is MD5, due to the discovery of security flaws in production networks, implement secure hash algorithm 256 bit or higher. So while hashing can detect accidental changes, it cannot guard against deliberate changes. There is no unique identifying information from the sender in the hashing procedure. This means that anyone can compute a hash for any data as long as they have the correct hash function. For example, when a message traverses the network, a potential attacker could intercept the message, change it, recalculate the hash, and append the hash to the message. The receiving device will only validate against whatever hash is appended. Therefore, hashing is vulnerable to man in the middle attacks and does not provide security to transmitted data. So, in generally, means to say that this hashing algorithms used for your web applications for authentication purpose. So now let us see in this hashing algorithm how cracking the hashes. So to crack a hash, an attacker must guess the password. So the top two attack used to guess passwords are, one is dictionary and brute force attack. One is dictionary and another one is the brute force attack. A dictionary attack uses a file containing common words in this dictionary, common words, common phrases, and passwords. The file has the hashes calculated. A dictionary attack compares the hashes in the file with the password hashes. If a hash matches, the attacker will know a group of potential good passwords. A brute force attack attempts every possible combination of characters up to a given length. A brute force attack takes a lot of processor time, but it is just a matter of time before this method discovers the password. So, password needs to uh, needs to be long enough to make the time it takes to execute a brute force attack too long to be worthwhile. So, hashing passwords makes it more difficult for the criminal to retrieve those passwords. So, this is the cracking the hashes in a different way. One is your dictionary, another way is doing the brute force attack. So, I would like to stop this hashing algorithm. In the next session, we'll try to discuss what is salting.